For the determination of plastic limit, objective of test is determine the plastic limit for the given soil sample. So plastic limit is expressed as WT and it the amount of water that is less from liquid limit and more from shrinkage limit amount. So add this constant amount of water mixed in soil and if soil make a thread of 3 mm, then the thread of soil is begin to crumble. So at this stage of soil is known as plastic stage of soil. So needle scope of the plastic limit determination is soil is used for making brick, tiles, and also soil cement block in addition to its use as foundation for a structure. Apparatus required for the plastic limit test is porcelain piece, glass plate for rolling the specimen, airtight container to determine. So I start the screen share. So apparatus used for the determination of plastic limit in laboratory is first apparatus is porcelain dish. Porcelain dish is a porcelain container in which soil is kept and also get the soil sample and also mix the water with this soil sample. Second apparatus is glass plate for rolling the specimen. Third is airtight container to determine the moisture content. Next is the balance of capacity 200 gram and sensitivity is 0.01 gram. Next apparatus is used for plastic limit test is oven thermostatically controlled with interior of non-corroding material and to maintain the temperature around 105 degree to 110 degrees centigrade. So procedure of plastic limit test is first we have to wet the soil sample and that soil sample should be passing through 4.25 mm micron sieve and sieve obtained in accordance with IS 2720 part 1. So take a sieved soil sample of 20 gram and mix it thoroughly. Then take a distilled water and mix it thoroughly with the soil sample. So mix it thoroughly with distilled water in the evaporating dish till the soil mass become plastic enough to be easily molded with finger. Allow it to season for sufficient time for seasoning for the sufficient time of 24 hours or, or 4 hours and to allow water to permeate throughout the soil mass. So take about 10 gram of this plastic soil mass and roll it between the finger and glass plate with just sufficient pressure to roll the mass into a threaded of uniform diameter through its length, and the rate of rolling should be between 60 to 90 strokes per minute. Continue rolling till we get a thread of 3 mm diameter. So again knead the soil together to uniform mass soil, re-roll. So again re-roll of 3 mm diameter. So continue this process until the thread crumbles when the diameter is 3 mm, and collect the pieces of crumbled thread in airtight container for determination of moisture content. So repeat this test at least 3 times and take the average of result. Calculate to nearest whole number. Also, moisture content determination is done by oven drying apparatus. So, observation taken during this test is, this is the observation sheet. So, compare the diameter of thread at interval with rod. When the diameter reduces to 3 mm, then note the surface of thread for cracks. So this table, by the help of this observation table, we can find the plastic limit for the given soil sample. So first of all, we note down the container number, then weight of the container plus lead W1. Next observation is taken, that is weight of container plus lead plus weight sample, and that is known as W2. Next observation is weight of container plus lead plus dry sample, and this is known as W3. Then find the weight of dry sample by above observation, that is W3 minus W1. Then again calculate the weight of water of soil by the above values, W3 minus W2. Then again water content, calculate water content by the formula in percentage, that is W3 minus W2 divided by W3 minus W1 into 100, where W3 is the weight of dry sample, W3 is the weight of container plus lead plus dry sample, W2 is the weight of container plus lead plus wet sample divided by dry sample minus weight of container plus lead. So this value gives the water content and also calculate in percentage. So we can find from this case average plastic limit for the given soil sample. So we can also find plastic limit and also plasticity index tightly from the above information. So see the procedure in the laboratory. So we can share the screen and see the procedure in the lab. This is the glass plate. This is the metallic rod of diameter. This is the spatula. This is the sample container. This is the thermostatically controlled. And this is the 425 micron IS sieve. So first we have to do the sample which is passing 425 micron. So note down the weight of the sample. Add the distilled water into the sample thoroughly with help of spatula. Mix it so that the soil is in plastic state and it can be molded. So this is the state of soil. Now start to make a thread of approximately 3 mm on with the help of place thread the soil sample on glass and roll carefully, and the rate of rolling should be 80 to 90 mm. It the thread up to make the 3 mm dia of thread, and also compare this thread to rod of 3 mm. We knead the sample into a ball and again try to mold into a thread of 3 mm glass surface, rolling it with finger continuous repeat the process of it, just it become 3 mm dia of thread, and if it is crumble that means it is a stage of the limit. So collect the crumpled soil sample into a container and wet the sample, determining the moisture content. Pick the container number, then weight of container, that is empty container, that is 26.10 gram. Then weight of container plus wet soil, that is 32.29 gram. Container plus oven drying soil, that is soil is in dry condition, that will be 31.0. If we calculate weight of water by air to values, that is 1.09 gram. We will find the weight of dry soil, that is W2 minus W0, so 5.10 gram. Then find the content. So it will be, as per observation, is 21.37%. Example, content is 21.6%. The test with same procedure. So after the finding liquid plastic limit, we can calculate so with the help of plastic limit and liquid limit, we can calculate plasticity index, that is IP. So what is IP? WL minus WP. WL minus WP. So we can calculate percentage plasticity index of given soil sample. Plasticity index of given soil sample by the knowing WL and WP. This is the liquid limit. This is the plastic limit. So plastic limit for first case is 21.7%. Liquid limit is 35.7%. Then we can find plasticity index, that is WL minus WP equal to 35.7 minus 21.7, that is 7.0% for the given soil sample. So precautions should be taken in this case is temperature of drying oven, thermostatically oven controller should be 105 degrees centigrade to 110 centigrade for the calculation of moisture content. We can also find dry unit weight and shrinkage limit in laboratory. So for determination of shrinkage limit, calculate the shrinkage ratio for the given soil sample. So as the soil loses moisture either in its natural environment or by artificial means in laboratory, it changes from liquid state to plastic state. So from plastic state to semi-solid state and then to solid state. So volume changes also occur with changing water content. But there is particular limit at which any moisture change doesn't cause soil any volume change. So at this limit of water content is known as shrinkage limit of soil sample. So for determination of shrinkage limit in laboratory, we have to calculate the shrinkage ratio of the given soil sample. So soil which undergo large volume change with change in water content may be troublesome and usually volume change may not be equal. So a shrinkage limit test should be performed on a soil to obtain a quantitative indication of how much change in moisture can occur before any appreciable volume change occurs and to obtain an indication of change in volume. So the shrinkage limit is useful in areas undergo large volume change and when going through wet and dry cycle in case of earth dam. In case of earthen dam. So WS is known as shrinkage limit. Shrinkage limit. So apparatus used for shrinkage limit is similar as the plastic limit. So that is this or container that is made from porcelain, have dia 12 centimeter dia, spatula, shrinkage disc, circular porcelain or non-colloidal metal, C number having a flat bottom and 45 mm in diameter and 15 mm in height internally. So also shrinkage disc. Straight edge steel straight edge of 15 centimeter length, glass cup of 50 to 55 mm in dia and 25 mm height and also top rim of which is round, smooth and level. Next is the glass plate. Two pieces and each have 75 mm. One plate shall be plain glass and other shall be have bronze. Sieve of 2 mm and also 425 micron. Oven that is thermostatically controlled. Graduated glass having capacity of 25 ml and graduated to 0.2 ml and 100 cc. Balance of sensitivity 0.01 gram. Mercury for cleaning purpose. Wash bottle containing distilled water. So in this unit calculation we can run by this unit calculation we can run as W is equal to W minus V minus V naught divided by gamma W into gamma W divided by W naught into 100. So W is the moisture content of wet soil V is the volume of wet soil. V naught is the volume of dry soil. W naught is the weight of oven dry soil. So, by observation of this shrinkage unit test, we observe the data about weight of container, that is W1, weight of container plus wet soil, W2, weight of container plus dry soil, that is W3, weight of container in gram also, that is in the container, weight of dry soil, oven dry soil mass, that is W0, weight of water also, that is measured, volume of wet soil in and also calculate percentage water content, volume of dry soil in centimeter, and by mercury displacement method, weight of displaced mercury, specific gravity of mercury, and then shrinkage limit calculate and also shrinkage ratio calculate. The procedure of this test is, first of all, we have to prepare the soil paste, that is soil sample. So take about 100 gram of soil sample, that is sieve through 20 ml and 425 micron IUC. Place about 30 gram of ever soil sample in the evaporating dish and thoroughly mixed with distilled water and make a creamy paste. Use water content somewhere around the liquid limit. So amount of water is similar as liquid limit is. So filling the shrinkage dish, coat the inside shrinkage dish with a thin layer of Vaseline to prevent the soil sticking to the dish. Fill the dish in three layers by placing approximately one-third of amount of wet soil with the help of a spatula. Tap the dish gently on a firm base until the soil flow over the edge and no apparent air bubble exists. So repeat this process for second and third layer also till the dish is completely filled with wet soil. Then strike off the excess soil and make the top of the dish is should be smooth. Wipe off all the soil adhering to the outside of the dish. Wet immediately the dish with wet soil and record the weight of wet soil sample. Then air dry wet soil bed for 6 to 8 hours until the color of soil turns from dark to light. Also keep the temperature of oven should be 105 to 110 for 12 to 16 hours duration. Remove the dry dish, add soil from the oven and cool it in a desiccator. Then obtain the weight of the dish with dry soil sample. Again determine the weight of dry empty dish and record it. Then determine the volume of surface dish which is eventually equal to volume of wet soil as follows, and place the surface dish in an evaporating dish and fill the dish with mercury till it overflows slightly. Then place it with plain glass plate firmly on its top to remove excess mercury and pour the mercury from the surface dish into a mason jar and Find the volume of the surface dish directly. Record this volume as the volume of wet soil sample. So volume of dry soil observation is, first we have to determine the volume of dry soil sample by removing the sample from the surface and immersing it in the glass cup full of the mercury in the following manner. So place the glass cup in a larger one and fill the glass cup to overflowing with mercury. Then remove the excess mercury by covering the cup with a glass plate and with tongs and pressing it. See that no air bubble are intact. Then wipe out the outside the glass cup to remove the adhering mercury and then place it in another larger dish which is clean and empty. So place the dry soil sample on the mercury. It floats, submerges and it with the pronged glass plate which is again made flush with top of the cup. Then the mercury is spilled over into the larger plate. Pour the mercury that is displayed by soil into measuring jar and find the volume of soil sample directly.